Hello everyone. So, today we are going to start the clothing comfort related to thermal transmission. In earlier segments we have discussed the clothing comfort related to psychological comfort, psychological aspects we have discussed. Then we have discussed neurophysiological aspects, and in last segment we have discussed the tactile aspects of clothing, how our clothing transmit signals related to touch, pressure, all those aspects we have discussed. And today's topic is the thermal transmission. So, and it is a dry heat transmission through clothing, and how this transmission affect the comfort sensation of human. Okay. So, basically the transmission of heat and moisture, although moisture related part we will be discussing in the next segment, but the transmission of heat and moisture through clothing system takes place in two states. One is the steady state condition, another is in transient state condition. Most of the situations the transmission takes place in transient state condition. So, it is the human body is rarely in thermal steady state condition. So, always it gets changed, like the process involves in comfort are mainly physical, thermophysiological, neurophysiological and psychological. So, in this segment we will be discussing the thermophysiological aspects of clothing. So, that the thermophysiological aspects, it is basically associated with the thermal balance of human body. So, most of the cases we will see this thermal balancing and all aspects are not in steady state condition, but for our discussion we will consider some steady state situations. So, the first priority to be thermally comfortable is that we have to maintain our heat balance. Okay. Basically our body core temperature, we have to maintain our body core temperature, it is a 37 degree Celsius is the mean body core temperature for average adult, and its a range is maximum range is plus minus 5 degree Celsius. Beyond that we cannot survive. Okay. So, it is if it is more than 42 degree Celsius, then we call it as a condition which is known as hyperthermia, and if it is below 32 degree Celsius, then it is called hypothermia. So, we have different situations, and our clothing's main function is to maintain our body core temperature within the comfortable limit, although our physiological phenomenon activities try to always maintain the body core temperature at 37 degree Celsius, but our clothing has to assist that. So, two types of thermophysiological comfort requirements are there. One is the normal, in normal condition, normal thermoregulation in human body, which deals with the normal temperature which exists in the environment, and second is that it is a thermal distress, where the temperature is extreme, either in extreme heat condition or it may be extreme cold condition. In normal condition, normal thermoregulation system, which can be taken care of by our physiological processes most of the time. Our physiological process can take care of that, of this normal condition, but at thermal distressed condition our clothing has to come into picture to make ourselves comfortable. So, normal thermoregulator regulation in human body, where it is the core temperature is there, we have to maintain it is a constant temperature. It is measured as a rectal temperature, and the core temperature actually varies among different body organ. Normally within a smaller range it varies, and some organs they are heated by the blood flow, and in some portion they are cooled by flowing blood through them. So, that is how the temperature core temperature sometimes varies, although it is very close to 37 degrees Celsius. So, physical activity also raise our body core temperature, that we have seen in earlier segment also. With the high activity, so body core temperature increases rapidly. So, the rise in core temperature is proportional to intensity of activity level and also maximum oxygen intake. Okay. So, that we have seen already. So, the skin, now coming to the skin temperature. So, skin that is surface temperature varies from part to part. So, our if we see our at different body parts, the skin temperature is different. So, it is cooler if it is away from the origin of heat, that is central part of the body where our heat mainly generates. If we go further away from this central part, that like hand or feet, it temperature normally it is lower than that part. Okay. So, average skin temperature, how to get the average skin temperature? We can calculate the average skin temperature by weighted mean method, where if we know the temperature of a particular zone and mean area of that zone. So, if we get the weighted mean, so we will get the average temperature of skin. So, it varies from with the ambient temperature also. So, if the ambient temperature changes, so that the skin temperature and mean skin temperature will also change, but it does not change with the level of activity. So, intensity of work does not change the skin temperature, although it changes the body core temperature. So, it is just almost opposite way it works. The core temperature normally does not get affected with the environmental temperature, whereas the skin temperature gets affected, and reverse is in case of the level of work. With the intensity of work, core temperature changes. So, if we see the skin temperature at different zone of our body with the cold environment and the warm condition, they change. So, at a different zone, if you see the finger, it is at the cold condition, it is as low as 21 degrees Celsius, okay. And foot also it is a 21.4 degrees Celsius. So, these are the indicative value, and if we see in the warm state, warm condition, the skin temperature for most of the places is almost around 35-36 degrees Celsius, and the difference is less. The variation in temperature is less at height or warm condition, and whereas in cold condition the difference is from say 21 degrees Celsius to say 33 degree, 34.5 degrees Celsius at the back of the neck. So, this at different zone, if we see it is the temperature is different, and this and that if we take the weighted mean of this different zone, we will get the mean skin temperature, and that for all all the calculations we use this mean skin temperature as the reference. Okay. because the heat flow from our body to environment, or if we receive the heat. So, it actually the reference point is the mean skin temperature. So, how is it being calculated? So, it is calculated by like T skin is the mean skin temperature by taking the weighted sum of the skin temperature over various parts of the body, like it is a 0.12 of temperature at back. So, if we take the temperature at back, skin at back, so if we multiply by 0.12, then 0.12 into chest, then we take the temperature in abdomen, then we take the temperature of arm, thigh, leg, hand, head and foot. So, and this coefficients are approximately the proportion of area covered by this particular zones, and ultimately we get the mean skin temperature, and then the mean body core temperature we can calculate by again by deriving the weighted mean between the core temperature and the skin temperature. So, core temperature is it is basically 1:2 ratio. It is this is a core temperature, it is multiplied by 0.67 plus 0.33 into skin temperature. So, at then we get the mean body temperature. So, this is the way we calculate the mean body temperature and mean skin temperature. Now, that in normal condition, how do we get the thermoregulation? So, it is achieved by automatic regulation system, that is by our physiology, and which matches the heat loss and heat production. So, physiologically it is automatically gets matched to keep ourselves comfortable, whatever quantity of heat we produce, and that heat has to come out. So, if the rate is imbalanced, then we will feel uncomfortable, and which is sensed by the brain. Basically it is the system which is located in hypothalamus in the brain, and ultimately we get a sensation of cold and warm sensation, but effectively the it has to be balanced. Now, the temperature sensor in the brain respond to the local thermal stimulation from different part of the body. So, at from different part of the body we get, as we have discussed earlier, we get the tactile sensation. Similarly, brain receive the response from different part of the body, the temperature sensation, which is sensed by the thermoreceptors, and then the cells in the hypothalamus receive the sensations, and ultimately it gives the our sensation, okay, and which is received by different sensors. Now, on the other hand, the other regions of the body, okay, that brain gets the sensation, the overall sensation from different parts of the body, but other regions like spinal cord and abdomen, they have some thermal sensors which actually respond to the local temperature. So, one is the overall temperature, and another is the local temperature. They also they sense that local temperature response. Okay. So, what is thermoregulation? Thermoregulation is of a body. It is an interaction between core and surface temperature. So, that is the interaction within the body, and it maintains the reference point on the surface and the core. So, that way it keeps balance. Okay. So, it activates appropriate response when deviates from the reference point of the. So, when it always tries to maintain the balance, if it deviates, then it is activated by sweating, by heavy breathing, by constriction, by dilation, shivering or non-shivering, whatever way. So, our body physiology always tries to maintain the balance. So, in case of any deviation, that particular one of these or maybe at a time many such physiological activities get activated. So, and apart from this thermal activities, so there are some non-thermal factors also which affect the temperature regulation of our body. These are all related to the shivering, constriction, all these things they are related to thermal, directly thermal activities. So, some non-thermal factors like these are the non-thermal factors like electrolyte balance and hydration rates. Like electrolyte, with by electrolyte balance we can, our body can maintain the thermal regulation, like sweating, it is by electrolyte balance. So, increased sweat secretion and electrolyte loss in sweat are the most important mechanism in temperature regulation. So, sweat loss and sweat loss, by directly sweat loss we try to keep our body cool, or by electrolyte loss. Okay. So, and acclimatization, that is insignificant changes occur. So, and most important is a local adaptation due to heat and cold involved either by vasoconstriction or vasodilation. So, this actually this is most important for local adaptation, but acclimatization is it does not work to it, its effect is insignificant. So, this acclimatization we have discussed earlier also. So, how to maintain the body comfortable, and after this normal thermal regulation, now we will discuss the thermal distress. So, thermal distress is that it is a condition when a person is exposed to extreme environment. It may be too cold or may be too hot, okay? And they actually they cross the threshold limit for the normal thermoregulation system, and thus the control over our thermoregulatory system is lost. So, this our thermoregulation, that this system works in a particular temperature range. If it goes beyond that, then it will our thermoregulation will stop. So, that means we may stop shivering, we may stop sweating. So, all this if it is actually beyond that, if it is either too cold or too hot, then we will have problem, and our we have to bring down the temperature, or if it is too hot, or we have to warm up if it is too cold by using proper clothing. Now, let us see what is happening in thermal distressed condition. In case of extreme heat condition, so this is the extreme hot environment, and our body core temperature we are trying to keep constant, it is within 37 degrees Celsius. So, at that extreme hot temperature, if we want to keep during the extreme hot temperature, if heat loss to the environment is sufficient by sweating and evaporation that we have seen earlier, then body temperature will remain at 37 degrees Celsius. So, heat loss has to be sufficient at a high temperature, because at high temperature we know that most of the mechanism it works that we receive, our body receive heat. So, only mechanism is that by sweating and evaporation. So, if we can sweat properly and that sweat can be evaporated perfectly, then we can maintain our body temperature at 37 degrees Celsius. But if it does not, then the body temperature, body core temperature may increase beyond that 42 degrees Celsius. That means high condition of hyperthermia may take place in extreme hot condition, where that if we the heat loss is insufficient. So, we cannot lose heat by maybe by sweating, body will produce excess heat for liberation. So, our body and the body core temperature increases. So, this condition is known as the hyperthermia, and here what happens, our blood pressure will drop. So, we will actually gradually go towards the heat stroke. heat stroke so may take place. So, there may be other effects. So, heat cramp may take place, heat rash, failure of sweat glands, that is basically very severe condition, where a sweat gland will stop secretion of sweat. So, that we will not be able to actually cool our body by evaporation and sweating, and we stop sweating. Similarly, for extreme cold environment, so body core temperature, if it is below 32 degrees Celsius, if it is extreme cold, if we cannot protect. So, normally we can easily protect our body from extreme cold temperature by increasing the number of layers. Okay. But if we cannot do, what will happen? So, in that case, so our body will continuously release heat from the body. So, that means heat loss is more than heat production. So, if we do not wear clothing properly, so in that situation will happen, and this we can control by proper insulation, and then drop in body core temperature. So, body core temperature will gradually come down and it may reach below 32 degrees Celsius, and this situation is known as hypothermia. So, hypothermia condition at what happened here. So, at the core temperature, so core temperature should be around say 37 degrees Celsius. If it drops by 2 degrees Celsius, what will happen? The person becomes confused and shivering stops. So, shivering starts around say 1 degree low or couple of degree, but if it is around 2 to 3 degrees drop, then person will stop shivering. So, he will become confused. Then if it drops further, so at about 30 degree Celsius core temperature, the person become unconscious. So, that is very severe condition, and our heartbeat may stop so at 27 degrees Celsius, because it is a very severe condition, and if one can take precaution, proper precaution by wrapping warm cloth, so that can be recovered. So, basically that around say 30 or 32 degree, below 32 degrees Celsius, we should take this precaution. This we should actually wear protective clothing, but below 32 degrees Celsius, when hypothermia starts, then there will be problem. Okay. So, we cannot survive around say 27-28 degrees Celsius of core temperature. So, the human body has very intelligent thermoregulatory system to ensure the body core temperature around say 37 degrees Celsius. So, it is by vasodilation, when body core temperature increases. So, due and vasodilation, that is increasing the blood flow. So, we can increase the body core temperature, and also when the blood flow to the skin. So, in that way our body, if it is so body when body so that we can actually release our body heat by excess rate of blood flow, and also by sweating. So, these are the mechanism which we can control our body core temperature. We can reduce our body core temperature by sweating and evaporation. And if it is at the cold temperature, so vasoconstriction comes into picture, where when the body core temperature decreases, so we reduce the by vasoconstriction, blood flow is automatically reduced, so that it body temperature, body heat remains inside the body, and also to enhance the heat body, the metabolic rate also increases by stimulating the muscles, which results in shivering. By shivering and higher metabolic rate, automatically we can increase our body core temperature. So, this is the system of thermoregulation in our body. So, this is the human body, that it is our here we sense the temperature from environment by the receptors present in the skin, our brain sense and evaluate that sensation, and our physiology, through physiology shivering, sweating, we can maintain our core temperature. So, this is our physiology, and to actually enhance, to help this physiology in distressed condition, we have to use our clothing. So, now what is the importance of clothing in maintaining our body in thermally comfortable condition. So, we can, without cloth, we can be comfortable between a temperature of 26 to 30 degrees Celsius. It is a comfortable temperature. That means, if we normally we can survive comfortably without any clothing. So, maybe to 26 to 30 or maybe 32, 33, that range varies. This is the indicative range, but if we use clothing, then we can survive comfortably within a wide range of temperature, maybe minus 40 degrees Celsius to plus 40 degrees Celsius comfortably. Okay. So, that is how the wide range we can in that wide range we can be comfortable by using proper clothing. Okay. So, clothing creates comfortable microclimate, and that temperature of microclimate which is important. So, that it is a, and clothing, if we see, it covers most of our body, typically say 75 to 90% of our body is covered by clothing. So, most of the body as it is covered. So, our proper designing of clothing, proper selection of clothing is important to maintain our body thermally comfortable. So, to maintain the thermal exchange with the environment. So, now let us see for thermal comfort, what are the basic factors in comfort. So, typically it is most commonly we tell for thermal comfort, it is a air temperature. Air temperature is the main factor of thermal comfort. If we know the air temperature, then we can tell, okay, whether we will be thermally comfort or not, but it is not true. So, although it is an important indicator, thermal air temperature is an important indicator, but it is not the only. So, neither valid nor an accurate indicator of thermal comfort or thermal stress. So, apart from air temperature, there are many other factors. So, here it is air temperature should always be considered in relation to other environmental and personal factor. There are 6 such factors in that for which the thermal comfort of a human body it depends. So, these factors are either environmental factor or personal factor, or environmental and personal factor plus clothing related factors. So, these factors may be independent of each other, but together contribute to the person's thermal comfort. So, this the 6 factors which we are going to discuss, they may be independent, but effectively all these factors together give our sensation of thermal comfort. So, what are these factors? So, these factors we can divide into 2 parts. One is environment related factors. So, these are, as we have discussed, air temperature is one of the most important factors. Then radiant temperature. Radiant temperature we will discuss any warm object which radiates heat. So, that is a radiant temperature, like air velocity, humidity. So, these are the factors which directly affect our thermal comfort. So, we will discuss detail air temperature. Suppose if it is a warm air temperature is a hot air, but if there is air velocity, air blowing, so we may feel different comfortable. So, basic comfort sensation will be different. So, at different at certain air temperature, if we change our air velocity or humidity, our totally comfort sensation will be different. So, we cannot say only air temperature factor thermal comfort. So, this all these factors are together gives a thermal sensation. Apart from these 4 environment related factors, 2 other factors, one is clothing related factor. So, it is a clothing insulation, and next is the personal factor. So, it is a what is the metabolic rate and all, like a particular air temperature. So, or radiant temperature or air velocity or air humidity, if we change the clothing insulation, our comfort sensation will be totally different. So, we have to, or if we change our metabolic heat, so total comfort thermal comfort sensation will be different. So, all these 6 factors in combination gives us the sensation of thermal comfort. So, let us discuss one by one. So, environmental factors, it is if air temperature is there. So, in air temperature, this is the temperature of surrounding air. Okay. So, this air is actually our body is surrounded by this air. So, this temperature is very important, because our heat flow from body to environment depends on this surrounding air temperature. If it is low, then our body and it is as compared to our skin temperature, our body will start releasing heat at a higher rate. Okay. And if it is high, then we will keep receiving heat. So, air temperature is very important. So, after that it is a radiant temperature. So, what is radiant temperature? The thermal radiation is the heat that radiates from a warm object. So, on any warm object, the object may be oven, may be fire. So, that warm object may be anything, any warm hot iron, okay, this may be heater. So, that radiates heat. So, that depending on the temperature of that or fireplace. So, we our comfort sensation, thermal comfort sensation depends. Okay. So, radiant heat may be present if there are heat source in an environment. So, if there is no heat source, so then radiant heat is not there. So, at the corner of the room, if one fireplace is there, so then it will change total heat equation, because radiant heat will start radiating heat and our body will start receiving that heat. So, radiant heat is very important. So, radiant temperature has a greater influence than the air temperature on how we lose or gain heat to the environment. So, that is very important. So, air temperature, it is basically it creates the temperature gradient through which our body can release heat by say conduction. Okay. But the radiant heat, it is important, as we have seen earlier, the radiant heat, it actually changes with the the power of 4th order of the temperature. So, that radiant heat is the major factor on our thermal comfort. Okay. So, it is a greater influence how we lose or gain the heat. Okay. Now, let us see, our skin absorbs almost as much radiant heat as a matte black object. So, it is our body, whatever radiant heat our body will absorb that heat. Okay. So, we have to our body cannot normally reflect back. So, whatever heat radiant heat is there. So, if it is projected in our body will start absorbing the heat, and will get our body core temperature will get warm. So, that means if we are in front of fire, so that and if we are not clothed properly, so our body will start receiving the that radiant heat and will get heated up. So, and this may be reduced by wearing reflective clothing. So, if we can wear proper clothing which reflects this radiant heat, that radiation, so that way we can keep our body cool. So, the example of this very common examples of the radiant heat is a fire, electric fire like heater, electric heater, furnace, steam roller, oven, cooker, dryer, any hot surface, okay, any machinery, molten metal. So, these are the source, common source of radiant heat, and for actually to prevent this radiant heat to heat up our body core, to increase our body core temperature, we should wear a proper heat reflective clothing. So, this is one some examples of. So, for say firefighter for to actually to in addition to other layer to prevent him from radiant heat, some reflective coated fabrics are used. So, there are different these are the typical characteristics of a reflective coated cloth. It should be quiet, but that means it should not make sound or it should be breathable. If it is not breathable, then our moisture will get accumulated, we may get heated up. Very high reflectivity, it should create comfort, it should be washable, okay, and disperse heat evenly, okay. It should be lightweight. So, these are the characteristics of any reflective coated clothing. So, next factor is so after air temperature, radiant temperature, next factor is the air velocity. So, it is an important factor to control the thermal comfort. Okay. So, because people are sensitive to it. So, it is a extremely important factor. This describes the speed of the air moving across the person, which may help cooling the person if it is cooler than the environment. So, one is that it is if directly if it is cooler than the environment, it directly comes into contact with the body and it cools the flowing air, normally directly cools the human body, just like if we stand in front of AC air conditioner, we immediately the cold air will cool our body, even if it is warm. So, then also our body will get cooled. So, because the movement of air brings the hot air from the body from around the body, and our forced convection will come into picture. So, for forced convection, so we need convective heat, higher amount of convective heat loss will be there if the air movement is high. But on the other hand, still and stagnant air indoor, okay, in indoor environment that are artificially heated, okay, will cause the total environment stuffy. That if it is the air, if there is no air movement, so it will become humid and the body heat will not be able to actually to come out from the body at a required rate. So, we will feel uncomfortable. So, moving air in warm and humid condition can increase heat loss through convection without any change in air temperature. So, even if the air temperature is high, even if the humidity of the air is high, if the air movement is there. So, if we increase the air movement, our body will be cooler, will have because the convective heat loss will be high. So, if the air temperature is less than the skin, temperature will be significantly increase the actually that it will increase the convective heat loss property. So, if in case of high and humid condition, high temperature and humid condition, there will be a loss of heat due to convection, and in case of lower temperature also it will significantly increase the convective heat loss. We may feel cooler. So, physical activity also increase the air movement. So, if in case of the stuffy weather, in case of the still air, if we start moving, if we start walking, that movement will bring the forced convection. So, that air movement with reference to our body. So, air velocity may be corrected to account for personal level of physical activity. So, that physical activity if we increase, the relative air velocity will be there, and that way we will feel cooler. And next is that after the air velocity, next is the humidity. So, relative humidity between say 40 to 70, it does not affect the comfort, thermal comfort sensation. It's our required humidity is between 40 to 70%, but if it is more, what happens? So, and then our relative humidity may be higher than 70% on warm and hot environment. So, if that be the case in a hot and warm environment, that at more than 70% relative humidity, then even if we sweat, that our sweat will not get evaporated quickly. So, our body temperature will not be actually lowered, will not be reduced. So, we will not feel comfortable. So, we need proper humidity. So, high humidity environment have a lot of vapor in the air, which prevents the excess evaporation of sweat. So, that is how the will at high hot and humid condition we normally feel very uncomfortable. So, in hot environment humidity is important because less sweat evaporation when humidity is high. So, basically humidity, effect of humidity is very closely related with the temperature of the environment. So, if it is at low temperature, at temperature is lower, then we can, if humidity is little bit high, then we may not feel that much uncomfortable than if it is the temperature of air is high. Okay. At higher temperature, if the humidity is high, that means it actually it activates our sweating system, and that will actually affect the evaporation. So, the evaporation of sweat is the main method of heat loss when the temperature of environment is high. So, that way at hot environment the humidity should be low. So, because otherwise we will feel uncomfortable. When the vapor impermeable PPE, personal protective equipment we wear, vapor impermeable at high and high humidity condition, at hot condition, then we feel very uncomfortable because we start sweating and sweat does not get evaporated, and this also happens if the this PPE does not have a pore. Actually, the water vapor permeability, if it is if a person wearing this type of PPE, asbestos or chemical protective suit, the humidity within the microclimate of the garment may be very high and we feel very uncomfortable. Okay. And now we have discussed the 4 factors of environment related factors. So, next class we will continue with these factors. So, some other aspects we will discuss. Till then, thank you.